Hey, here we are again. This this is Astronomy Daily Live coming at you at 2 hours UTC every single day. And today is at least UTC time. It's the 11th of February 2018. So, hey everybody who's watching live and everybody who is going to be watching this in the future. Howdy, howdy. Hope everything's well with everyone here. Um, Yeah, little bit of excitement today. I I'm I'm located in southern Arizona, southeastern Arizona specifically, and primarily number one reason why I'm here is because it's dark, and that's number one thing, dark, like above everything else, right? The second most important thing, somewhere maybe here, okay, it being dark is like, way up there, but somewhere around here is quiet. Um, Somewhere around maybe here or so is that the climate here is extremely benign, so we don't get a lot of anything. We get a nice monsoon in the summertime. Um, the wind blows a little bit here, but no earthquakes, no hurricanes, no tornadoes, um, nothing really. The only thing that we really have to worry about at my location is wildfire. And although those are pretty rare, supposedly, last June we had a lightning strike, and that got pretty hairy for a while. There were evacuations in my area, so we were never asked um, to leave. We were pretty much ready to go, uh, but yeah, that was a little bit hairy. And just today, in the same place that almost the same place that burned last June, there was another wildfire today. This was human caused. They were, burning stuff and didn't realize that the wind was going to kick up, and fire got away from them. And so we had smoke all day long. And, you know, we're wringing our hands here a little bit, but come nightfall, the wind dies down, and we're sort of able to look over there to see if we can see any fires on sort of our side of the mountain, and we don't see any. So I think we're okay. Just a lot of smoke, and yeah. So that's the only real hazard where I am. It doesn't get really cold. It can get cold, but it doesn't get really cold. I mean, a cold winter um, will drop into uh, the single digits, high teens Fahrenheit for maybe a little while. Um, this winter has been extremely, maybe not extremely mild, but quite mild. We've dropped into the teens a few times, and that's about it. More or less, it's been pretty nice, pretty nice. So yeah, let me. I'm gonna pop on to uh, machine. My Linux machine is freezing up on me, which probably means it's playing my live stream. I don't quite understand this. Anybody with knowledge of this kind of experience might be able to help. On my Linux machine running Fedora 24, I haven't upgraded yet. Um, Live streams on YouTube freeze my machine up. It just totally freezes. I mean, I can't even move the mouse right now to do anything. So this this machine is probably very hosed. So this is the one that I use the chat in though. So probably what I'm going to have to do, arg, is reboot this machine, which is a real bummer. But I'm going to do that. I'm going to push the button here. It's something that has to be done. Sorry. 5, 4, 3, 2, 1. There it goes. Ah, it's so painful. So I'll let it sit for a few seconds here. And then I'll restart it. I hate doing that. But for some reason, only live YouTube freezes my machine in that long. So, okay, well, I can move on. So this is a live stream every single day, and we talk astronomy here. And whether you're new, whether you're an amateur, whether you're like an advanced amateur, or if you're a pro, you are welcome in here. Join in the circle, and yeah, let's talk astronomy for a while. And we can stay really, really light. We can go really, really deep. Um, uh, if you've got questions to ask, for sure, ask them. As soon as my chat comes back up, I'll be able to see that. I'm also on Discord as well, and there's a chat there. So I think I have that in the description, a link to my Discord server. I guess that's what they're called over there. So go check that out. That's a great place to have, sort of ongoing conversations either during the live stream or anytime. So, there's an advantage there. If there's anything interesting in the chat here on this live stream, you can certainly copy and paste and get that info. Whoop, hold on, I got to push one more button. I'm gonna have to put you down. Now I've got mouse control. I'm gonna log in. Sorry, little machine. So yeah, Q&A for sure. If you have any questions or anything, go ahead and ask away. I might be able to answer them, or maybe point you in a direction that can get you some answers. Definitely other things to talk about are telescopes and gear and any kind of instrumentation, data analysis, how to collect data, what to do with it afterwards, presentation of data, those kinds of things. We can get into astro-art. I always like to look at journal articles. I like to do that from time to time. Archive.org is absolutely awesome, and there are a few other interesting ones as well. So I'm going to, as soon as this pops up, I'm going to pause the live stream. It says that I'm live in 22 minutes. That's pretty funny. Let me reload this. Reload. See what it does now. I just watched some of the live stream from a lady who is, her YouTube channel is called stemulus, STEMULUS. And what I'm going to do is, let's see, can I do that? Nope, it's not going to let me do that. So let me get the chat up. Hey, Uncle Bill. Hey, Nancy. Nice to see you here. Glad you popped in for a few moments. That's, as I keep saying over and over again, that's kind of the cool thing about having a daily thing is that you know, friends can pop in and say hi, chit chat a little bit, and exit. So yeah, you come on by whenever you like and stay as long as you want. Yeah, Uncle Bill, I don't know. Hey there, Tom. Nice to see you too. Glad you can come by. I'm I I have, I guess, sort of a different perspective on the different flavors of operating systems. I don't have, I guess I don't have the sensitivity to those kinds of things. So switching between different flavors of Linux or different flavors of Windows or any of those, I've never encountered any kind of trouble, or even a sensitivity to, wow, this is really different than this. I mean, there are obvious differences between like Windows and Linux, but I don't know. I I sort of attribute it to I just don't have that kind of sensitivity. So I don't know if that's a good thing or a bad thing, but I seem to uh, be um, yeah. I don't notice those kinds of things. Maybe I don't use them in a particular way or anything. I mean, my um, um, use of Linux is mainly in sort of programming mode. So I mean, it's all I need is a console and VI and and a compiler, and I'm pretty much done there. So doesn't really matter if it's Red Hat or Fedora or Debian or any of them. I don't really care, and I guess I will just sort of adapt. And Fedora, I started running several years ago, and mm, it's just it's sort of an arbitrary choice. I think it was coming off of Red Hat, and I had used Red Hat before. Not that um, I have any kind of thing for Red Hat um, um, or Fedora. It's just sort of a random um, choice. So next time when I get a machine, maybe I'll do Debian or some of the other ones just to try them out. I figure as long as they can compile and I can run VI, I'm pretty happy camper. So, and maybe that's it. I don't make huge demands on my um, operating system. So gradually signing off. Yeah. Well, that's cool. That's cool. Cool. What was she doing? I was watching her earlier doing some artwork. Was that still going on? That seems like an awfully long time. Maybe she was doing some programming and stuff. I I really like her. She seems to well, I mean, it's obvious that she has a lot of experience and knowledge in a lot of things. So yeah, that is nice to see. Nice to see. As opposed to sort of a specialty in one particular thing. So which I see as um, I don't know. It's okay, but I guess I get bored with those kinds of things. If I stick with one thing for too long, I kind of get tired of it. Um, so yeah, yeah, I I too like to have a um, uh, a much broader. I like to go broad and deep. So if I can do both of those things, then I'm pretty satisfied. So wow, she's been doing the artwork thing this whole time, because I thought I was watching her maybe like 4 or 5 hours ago. Maybe it was sooner than that. I kind of feel as though my day has been robbed because of this slight concern with a fire. So really feel I've been gypped. But anyway, I was watching this lady. Now I popped that chat out, so now I can go to her YouTube channel as long as I can hit the right buttons here. What? You'll go. Oh, I got to do this one. There it is. So yeah, her YouTube channel. Let me put that on the as soon as I get it up here. It's one of those funky ones. So I'll put this in the chat just so you can. And there's Bob Dog. Hey, nice to see you back for a little while at least. Glad you stopped in. I'm trying. Paste her link. So there you go. Hope everything is good up there in ice cold Alaska. Um, Wonder if you've ever had a chance to take a look at the ISS up there and see how high it gets above the horizon. As I recall, we were looking at that a while ago, and I think the highest that it was getting was like 22 or 23 degrees above the horizon. So you can still see it, but that's getting kind of low. It's getting kind of low. Yeah, glad you stopped by. Uh, so yeah, this her name is Steph, and she's some kind of engineer at a company that builds satellites. Um, these are, I guess, the project that she is working on at the moment uh, are are sort of these Earth imaging satellites, and I guess there's a cluster of them up there, and they're building more. And I think she said 1 meter resolution, so that's not incredibly high res, but especially from Leo. But yeah, that's all right. That's the uh, size of a desk, so that's not too bad. Not too bad. So yeah, she I I really I appreciate her enthusiasm and her passion. I didn't mention anything at the time, but she talks very fast, and it sort of reminded me to pay attention to that a little bit. Um, I don't think that I talk too fast, but if I do, uh, somebody please let me know. So I think I'm a relatively slow talker, but uh, haven't really paid much attention to it. But yeah, she was talking really fast. Either probably a combination of just being excited, um, but also maybe some nervousness and yeah. But I think mainly excited. I mean, I really appreciate that kind of enthusiasm, and I want to support that for sure. So check her channel out. Make sure to subscribe. Um, it's got some good stuff on there. So and yeah, it's we've made a huge mistake in sort of ignoring and knocking down and knocking out half the population of the planet. So to see sort of a representative from that half um, come on and do what she's doing is yeah, yeah. It's I keep saying this over and over and over again. It's like it's about time. It's about time that the other half of the world uh, uh, gets the attention that I mean we're missing out, guys. We're missing out a lot, and don't worry about it. Don't worry about it. You can only make things better. Oh, the drink of choice tonight is for sure the hydrogen hydroxide because uh, it's very relaxing, and that is definitely what I need now for sure. Is just to relax. So cheers on that. Nice to see everybody. I hear somebody new. I don't know how to pronounce that name. SP3. Hey, glad you can join us. If you don't know what you've fallen into, this is Astronomy Daily Live. This is a daily live stream um, starting at 2 hours UTC every single day. And we talk astronomy for an hour, maybe longer. It sort of depends on what is being discussed. And this is just a very casual, but hopefully high quality um, uh, thing. And it's just a circle of friends. Consider this, we're um, um, sitting around just chit chatting about all things astronomical. Um, Definitely want to bring in a little bit of science as well, and we can talk about rockets and all of that, too. Because one of the cool things about astronomy is that it is a science that sort of encompasses everything. So from the subatomic to the cosmological. Spare rib, spear rib, spare rib. Okay, very, very cool. Well, I'm glad you're here. Welcome to the circle. Um, Stay as long as you want. This is a daily show, so you know, stay as long as you want. Come back tomorrow. Come back next week. Um, Best thing in the world that you could do in terms of support at this point is to subscribe, and you can turn on notifications so you know when this is happening. As I said, it happens at 2 hours UTC every single day. So depending on where you are on the planet, you're going to have to figure out what time that is for your local time. Um, I'm over in southeastern Arizona, United States, and so I'm on Mountain Standard Time, which is 7 hours behind UTC. So for me, it isn't quite the 11th of February yet. It's still the 10th of February, currently at 7:24 p.m. So yeah, you'll have to figure out what time that is, and if you want to cheat, set the notifications on, and you'll be notified when I go live. I'm looking at somebody else too, uh, and I don't know how to pronounce this one either. So I'm just going to call you U2H4 for now. So welcome. Thanks for dropping into the circle. This is just a casual talking about astronomy stuff. So Tom Tom is saying that he saw this on space.com. Radiation will tear Elon Musk's rocket car to bits in a year. I was thinking about that too, and if you if you look at the live stream, um, I think the paint on the car was already starting to bubble. It looked really, really, really rough, and I'm really surprised that the uh, whatever is making up the seats and everything, probably leather, but if it's plastic, it's like how is that going to survive direct heat from the sun? Several hundred degrees, right? Because there's no air, there is nothing um, allowing it, to disperse. So it's like direct radiation, and yeah. So I'm wondering about that too. Apparently, I watched the press conference today that he gave after the launch, and he said that the spacesuit is you know a spacesuit. So I'm sure that's going to probably be okay because it's space hard. But yeah, the rest of the car, I mean, I've thought about that the whole time. I mean, I was sort of a skeptic about whether there actually was a car in there or not. I was hoping that there would be because it's great PR. It's it's just awesome. It's just very, very awesome. I think the folks on the Tomorrow Show today were talking about the fact that because there's a mannequin there, right? There's a mannequin. We can sort of relate. We can sort of put ourselves there, and that's very powerful. That's a very, very powerful thing to do. Um, it sort of gives one sort of an overview effect, sort of. Um, so yeah, I think that was extremely well played. But yeah, I worry about the temperature extremes, and you're getting like direct heat from the sun and incredible cold from the rest of the universe. And yeah, I don't know how it survived the 4.5 hours uh, spacewalk in which might keep you alive. Flight suit. Okay. Yeah, yeah. Yeah. If that's only a flight suit, then yeah, maybe it isn't necessarily space hard. So okay. All right. So that may have some trouble too, for sure. But yeah, well, I guess unfortunately there's no real way to monitor that. So the only chance we have is the next time it comes by Earth. And I think if I heard right, and correct me if I'm wrong, but I heard like 2026. Does that sound about right? Let's see. 2026 is in 8 years. And if it's on a pretty elliptical orbit with a perihelion of 1 AU, and I don't remember what the aphelion was. Was it 3.5? I'm going to go over to my Discord and see if anybody's over there. Got to turn that on. And then I will see it. I think I'm slowly twisting my. I'm in trouble. Uh oh. Oh no. I'm starting to twist my starting to twist this into a terrible disaster. I better not touch that at all. I wanted to see what David Sims had written about that if he did. I thought David Sims put up a aphelion. Maybe he did somewhere else. I don't remember where he might have done that. No, I'm not seeing it now. But I thought it was something like maybe 2.5, 3 AU, something like that. So an 8 year orbital period. That sounds a little long because Jupiter is 11 and it's around what 5 or 6 AU, something like that. So 8 years for for a 1 by 2.5. 8 years seems a little long. But anyway, I guess we will have a chance to observe it when it comes back. It's not probably going to be very close or anything, but we might be able to get you know. Oh, Tom. Okay, so Tom, you saw a 1.6 year orbit, huh? That actually seems a little short. Oh, it's up on the Deep Astronomy Discord. Okay, I'm gonna go over there and see if I can find it. Yeah, I knew I saw it somewhere. There it is. There it is. So, so at least according to this, aphelion is 1.32 AU. Huh. Hmm. Thought it went out to the asteroid belt. The asteroid belt's around 2.5, something like that. Hmm. So okay, well, that's that is definitely a continuing saga. So, but because it was launched from Earth, and even uh, that last blast, to get it, still messing with my wire, uh, into the orbit that it's in now, will bring it pretty close to Earth, and so I guess, yeah, at least according to David Sims over on Deep Astronomy's Discord server space chat channel. He's saying that the Roadster will pass Mars at a distance of 0.05 AU on the 7th of October, 2020. And, oh, okay. And then pass it again in 2035. Maybe that's just the close ones, though. So, all right. Well, that's an ongoing piece of info. It'll be back at some point, if we can, make some observations, maybe some spectral observations, um, to to see, to look at the colors and to see if there's anything funny about the colors that could tell us, whether it's all in one piece. Um, maybe when it comes back around, uh, it won't be a single point. Maybe it'll be like a cluster of points or a cloud. Uh, Maybe we won't see anything at all because it'll be just vapor. So yeah, I guess we'll just have to see how that goes. Pretty exciting though. I can definitely say for sure. Pretty exciting stuff. Pretty cool. So I'm gonna look at the chat here, see how that's going. Uh, Oh, well, Mrs. Elite Nugs, it's just insanity, especially this SpaceX uh, event that just took place a few days ago. I'm I'm down here I'm messing with a potential rat's nest that I'm trying to get myself out of. I think I might have succeeded. Maybe. I need two hands to do this, so it's impossible. Yeah, yeah, okay. Well, that's exactly the same data that I saw David Sims post. So yeah, yeah, I think we got to go with that. I'll probably hop on to the JPL Horizons website and see if they have any up-to-date info on that, because that's actually one of the target bodies right now. It's actually NORAD number 43205. So you can check that out. And what I'm going to do is generate the latest ephemeris and see if it has. Ooh, it does. So this is for epoch 245-8158.5. Don't know what date that is. Eccentricity is 0.2681. Looking for, got an inclination of 1.128 degrees. I don't know how to read these numbers well enough. So what I'm going to do is I'm going to post this. I'm going to post this information that I have from the JPL Horizons website, and I will post that in my Discord channel or server under the astronomy channel. I'll post that right now, just like that. And you can see if you can interpret that last bit. I'm not having any luck interpreting that last bit. The JPL Horizons website, if you don't know about that, that's an interesting one. You know, you definitely have to sort of know what you're doing. Whoops. You definitely have to know what you're doing when you're coming into this site. But once you do, it's awesome. It's awesome. You can, yeah, this is one of the fantastic websites. And again, you know, this is for anybody. Whoop, get in there. Why can't I paste? I want to paste. Why isn't that wanting to paste? Maybe because I'm just trying to do it left-handed. Who knows? Copy. I can copy, and then I can paste. Can't I? I should be able to paste. Paste. Okay, so there's the JPL Horizons website as well. So yeah, Tom, I wouldn't be too surprised at that at all. If you get onto my Discord channel, I would appreciate a link to that article. Somebody ran some numbers, right, and came up with that kind of appraisal, and I'd like to see that for sure. For sure. Wow, this thing is just not letting go. Look at that. It's just nasty. I'll figure it out. I'll figure it out for sure. That's what I was thinking. It's David's data, not mine. Okay, yeah. Yeah. Well, as I said, I just pulled that info off of the JPL Horizon site, so I would say that's probably pretty good data. But yeah, I don't know how to interpret it exactly. It's a bunch of numbers there. All right, well, cool. Glad all of you have come in. Um, hey, I just wanted to show off a little bit my sunrise this morning, if that's okay with you. Just some pictures. This is not exactly science, right? But it is some pretty pictures that I like to share sometimes. Let's see if I can find it. Here they are. It was just a really, really nice sunrise. So I got out and shot some shots. Whoop. Wow, I went way past it. Here we go. How does this one look? Okay, so let's just do that one. So there's that one. That's pretty cool. Nice color. Oh, no, I'll just keep it zoomed out. That's fine. Yeah, just move through these quickly. Nice colors though. Nice, nice colors. That's a nice palette there. And that's it. All right, we can go back to me now. I just wanted to share those. I really, really dig color. So that's nice. Very, very nice. All right, I am back. I need to scroll down here. YouTube chat broke the link. Posted the link on Discord. Cool. Thanks, Tom. I will go look at that. On space. Okay, cool. Radiation will tear Elon Musk's rocket car to bits in a year. Yeah, I'll be interested to see how they came to that conclusion. So yeah, thanks for that article, Tom. Definitely like to keep up on those kinds of things. Didn't I don't think I heard anything too interesting or exciting with Elon's press conference after the launch. He was obviously very, very excited and very, very, yeah, you know, looking forward to the future and all that. And yeah, yeah, he's doing it. He's doing it. So somebody has to, and so it might as well be him. It's fine with me. Okay, yeah, yeah. If you have to, that is the only way. But yep, that is the URL for sure. All right, well, cool. Enjoy, enjoy. Take care of those babies. They need you, and we need them. So yeah, take care. Thanks for stopping in. Stop in anytime. Make sure to share this. Um, you know, tell everybody that I'm doing this every single night, same place, same time. Come on in whenever you want. The door is open. Um, and yep, cool. Glad you could stop by anytime, anytime. Lots of clapping, lots of hearts, lots of thumbs up. What what could be better than that? How about a clear sky? Clear sky. That's about as good as that. So, as a kid, this was one of the books that I dove into a little bit. And I don't know if they're still doing these or not, but um, I found these to be really handy. And I remember now, a memory is coming back from um, it. It was what I'm remembering live is a comment that an astronomer made at one point that I heard, and was sort of not really upset, but just sort of like why 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 do you think that at all? And it had something to do with making astronomical observations and recording the information and all of that. And I don't remember the details now, but he was discouraging um, young astronomers from making like detailed observations or anything else. His or her, I forget even who it was, but it was it was more like, here's a form that you just have to fill out, and that's all the information, and that's it. And I came from you know reading these kinds of books where this this kind of book has um, a nice big list of binary stars in it. Here's the first page of that, and but as you can see, okay, all of this all of this is the binary star data. All of this, so that's more than half. More than half of the book is a very, very detailed explanation of how to observe, in this case, binary stars. And most of it, I was looking at it before I came on here, and most of it is very relevant to um, today. And it gets into, minute, excruciating detail. Um, so there's, they talk about the different types of of double stars, and they make these great diagrams, these really really cool diagrams, showing you everything. Very cool, very very cool. So that's the types of double stars, and they get into uh, what those types are, which are visual binaries. Those are the ones that you can see, hence the name. Um, Optical doubles, and those are stars that appear to be very close to one another, but actually aren't. It's just line of sight. So one star might be, you know, it appears here, and another star very very close to it, but if you were to look at it from like the side, right, one star would be here, and one star might be way back here. So it's just a line of sight thing. And then there were the spectroscopic binaries, and those are binary stars that are just way um, too close for us to see with like a telescope. Um, but you can see it in the spectra. So you take a spectrum of what you think is a single star, and you start to look at all the signatures of all the chemicals in there. It's like, hey, there's some weird things here that can't possibly be a single star. So yeah, you get to see that. Um, astrometric binaries. Astrometric binaries. These are apparently single stars which are deduced to be double by virtue of their motion. Okay. Hmm. Interesting. So then they go into how to observe these stars, and you can get into that. You basically, uh, yeah, just want to observe, the separation of the components. I mean, if it's a binary star, then there are only two, but a lot of times um, stars will appear, two or three or four or five. After about five or six, you start calling it a cluster. So, but yeah, um, uh, you measure, the separation of of the stars, usually in arc seconds. So an arc second is 1/60th of an arc minute, and one arc minute is 1/60th of a degree. So one arc second is 1/3600th of um, of a degree. The moon, the full moon, is about 30 arc minutes across, all the way across. So what's that? 1800, um, 1800 arc seconds across, just to give you a reference. Um, with a usual normal um, telescope, like a telescope like this, under good seeing conditions, I can I can I should be able to separate a binary star that's about maybe 3 or 4 arc seconds apart. So very very close, very very close. Binary stars are really really neat to observe, mainly because you don't necessarily need a big telescope to start observing a lot of them. Um, Many of them are relatively bright, and a lot of them have um, enough of a separation to be able to see them even in a small telescope. So you don't even need anything that large at all to really get into binary star um, observing. So I'm going to go through the rest of this moderately quickly here. I'm going to look over the chat, see if there's anything going on over there. I don't see anything. So observing methods, blah, 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 blah. So that's just that. So yeah, it just describes the various observing methods and using instrumentation to make measurements, in this case a micrometer on the telescope. That's kind of cool. I don't know what this is over here, but I'll show it to you anyway. Then it gets into recording observations and what you should be um, recording. Primarily, um, what you're going to be recording is, of course, where it is in the sky, and then the separation of all the components, be it two or three or four, anything else. Um, you want to measure the brightness of all the components, either in an absolute way, which is a little bit harder, or in just a relative way. So component B is a certain number of magnitudes um, fainter than component A. Usually, component A is sort of the primary. Um, Sometimes the more massive ones. Hey there, and again, I apologize for not being able to pronounce these amazing names, but Uhij, Uhij, hey, thanks for stopping in. This is just a casual coming together of friends, and we talk astronomy for an hour or so. So at the moment I'm talking about binary stars, and these books that I used to get into observing them. And binary stars are great, as I was saying, because a lot of them are bright, and um, many of them have separations that allow you, to see them through a relatively small scope. Can't really do too much with binoculars. It's not quite enough. Um, but there are, some visual binaries. The One of the stars in the handle of the Big Dipper, I think it's the second to last one. It's the one that is sort of the bend. Um, that is actually two stars called Mizar and Alcor, and that is a visual binary. Those two stars aren't actually gravitationally bound and orbiting one another. They're just line of sight. Uh, but that in the past, that was a way to test if someone had 20/20 vision or not. If you could separate those two stars naked eye, then your vision, is pretty good. So that's a good test. The cool thing about Mizar and Alcor is that when you look at them through a moderately sized scope like that one, this is a Celestron Nexstar SC8. So it's an 8-inch mirror down here. And then if I scoot over, you can see that's where I would put either a camera or an eyepiece. And this is a focusing knob that moves the primary mirror back and forth like that in order to focus. So the light comes in from the top, reflects off of this mirror. This mirror is concave, so it's like that. So it bends the light to a secondary mirror that's up here, and then the secondary mirror shoots it back down to the eyepiece. So yes, there's a hole in the middle of this mirror. So observing Mizar and Alcor with this kind of a telescope, what you notice is that each one of those stars is actually a binary. So while they're a visual binary, um, uh, just looking at them, um, each one of those stars is actually a true binary, where those two stars are actually gravitationally bound to one another, and they are going around each other around a common center. So very, very cool. You can see that actually, as I said, with this kind of a scope. A smaller refractor uses a lens up here. That might be a little bit hard. The separation there is pretty small. I don't remember. I might be able to find it in here. But anyway, so you like to measure the separation between those two. The relative brightness of the components. You want to note any kind of colors. There's a really great one. Great binary star called Albireo. It's in the constellation of Cygnus. You can see that in the early evenings, uh, in the in the summertime. So they're coming up early right now, but in a few months they'll be up in the early evenings, and you'll be able to see this star, Albireo, and it's a binary star that um, the color of its two stars is striking and absolutely fabulous. I'm not going to give it away. You can look it up if you want. Um, if you look at this particular binary star, what I recommend is, definitely look at it in focus, but then defocus it and spread that light out a little bit, and that brings out the color a lot more, and that is when the color really pops. So highly recommend Alberio uh, as a binary star, to go after. Awesome binary star. So yeah, observing binary stars, separation, brightness, color, and then position angle. And I'll just show this. So up in the sky, we can sort of designate that pointing north is 0 degrees and pointing south is 180 degrees, right? And so if you put the A component, sort of the primary star, and in the crosshairs there, the B component is going to be somewhere else. And let's see if we have any drawings of that anywhere. Probably not. Something that I'm going to look for extremely rapidly. No, I don't see anything obvious. But yeah, it's just measuring the angle from north as to where all the components are usually relative to the primary star. You notice you note all your observing conditions, what the temperature is, what seeing is like, and then you can record your observations, and this is how they recommend you record your observations. And I'm not showing this incredibly well, but you want to note the date and the time, position in the sky that you're looking. I've got an itchy nose tonight. The telescope that you're using, the magnification, how the seeing is. If you're using any kind of instrumentation, like a micrometer, or if you're using a camera, they recommend that you do a little drawing, which is neat. Yeah, so it gets extremely detailed. The Astronomical League, if you hook up with like a local astronomy club, most of them are associated with an organization called the Astronomical League, and that, as the name implies, is just it's sort of a umbrella um, uh, organization for all the astronomy clubs, at least in the United States. And the Astronomical League has a bunch of I don't know what they're called, if they're called clubs, but I do believe that there's a binary star club, um, and they provide you with the same kind of information, how to observe them, and they provide you with a list. And if you observe and make observations and notes um, on all the binary stars, all the multiple stars in this list, I think you get a little, like a pin or some kind of recognition, that you've done this, and you're put on the list, and you can move on to other things. They have um, deep sky observing. They have Messier observing. They have a Herschel list. They have yeah, all kinds of lists, all kinds of things that you can get involved in if you want to do that kind of level of astronomy, which is mainly amateur, going out and just spending the night observing, and so that's very awesome. very, very awesome. I did that for many, 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 many years. Definitely don't do it as much anymore, mainly because I'm into the science now. So looking around is fun. Definitely like to do that with friends. So I'll pull the uh, I'll pull the scope out and do a star party um, for friends. And hey, Uncle Bill, there's always something for tomorrow. Always. I am so just barely scratching the surface. It 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 goes really, really, really deep. So yeah, but we are a little bit over an hour, so probably time to start winding down at least. Uh, I've only had I think one sip of the hydrogen hydroxide tonight. So, ooh, maybe that's why I'm a little keyed up still because it just hasn't had a chance to chill. So, all right. Anyway, I don't know if these books are available anymore or not. Um, but I think they're still very, very relevant. And for me, this came in a 5 volume set. So this is volume one, double stars. I'm looking up. I've got it on my bookcase in front of me here. Volume two is planetary and gaseous nebulae. Volume three is open and globular clusters. Number four, which was my favorite one, was the galaxies. And number five is clusters of galaxies. So the thickness of the books increase. Um, Number four and number five, I would say, are about twice as thick as this one. So this is 118, 119 pages. So those are at least 200. And again, a lot a lot of these books is information. It's how to observe and who the observers were. But the last bit, as I was already showing, is the actual like list of double stars that they suggest observing. And for me, looking at this screen, it's backwards, so I'm not going to be able to read that really, really well. But let's see. So it gives the name, it gives the position, the right ascension and declination. It gives the magnitudes, the brightnesses of the components, the position angles, the separations, the date. I'd have to understand what the date is. Then there's some other information here too. But yeah, what I did is I sort of determined uh, sort of the smallest separation that my scope could do, and then I would go through the list and say, okay, I can see that one, and I can see that one, and I can see that one, and maybe I can see that one, and you just go through the list, and these are really, really nice because you can sort of you know be looking at the binary star through the scope and have this next to you and say, oh, okay, the primary there is magnitude 4.4 and the secondary is magnitude 8.9, and that sort of teaches you to get a sense of how bright things are and what the relative brightness is between those two things, right? So there are what 4.5 magnitudes between 4.4 and 8.9. So 4.5 magnitudes. Every magnitude is about a factor of 2.5 fainter. So got to do it. I've got to do it at least once per show, right? At hands reach. So it's roughly 2.5 to the 4.5, if I remember right. Yeah. So that's a factor of 61.7. So in the specific example that I just sort of randomly pull out of this book, right? An 8.9 magnitude star is almost 62 times fainter than a 4.4 magnitude star. So if you're a beginning observer, that's a useful piece of information to have. And then you can also compare um, uh, the position angle, so you can sort of get a sense of, of what that is. And you can also get a sense of scale because you know that in this case, this particular binary pair has a separation of 36.1 arc seconds. So you can look through your scope and say, okay, that's that's how far that is. It um, sort of gives you a sense of scale, and that is really really important if you're going to be observing and sort of navigating the night sky. It's nice to have a sense of scale. All right, I think it's about time to get out of here. I'm glad everybody stopped by. We had a pretty good crowd there for a little while, so uh, I'm enthusiastic about that. Yeah, this is going to continue uh, for a while. Still trying to get some traction. I think that will come in time. It's just a matter of being um, consistent and patient and hopefully interesting and not too rambly or anything like that. Please, let me know if you have any kinds of suggestions. Let me know because my number one goal when I um, uh, get started into things like this is that I always want to be better. I want to be getting better and better and better, whatever that means. That's sort of an organic thing, but yeah. So today's hopefully was in some ways better than yesterday's, and tomorrow's will be a little bit better than today. So yeah, all right. I'm going to let you go. Definitely respect your time and glad you could stop by. Um, Uncle Bill, I know that you're watching 5,000 of these at the same time, so glad you could um, come in here and hopefully it's continuing to be interesting and new. There's so much that can be talked about that there's no way to run out of material. There's just it's impossible. So yeah, hang with me. Any ideas? I am all ears. Definitely spread the word. I appreciate all the support. And yeah, I think I'm going to get out of here for tonight. I will see you again in a little less than 23 hours. All right. Oh, and by the way, in yesterday's show, I said the word astronomy 26 times. So yeah, pretty good. I don't plan those things. I don't try to plant words or anything like that. There's no way. There's no way that I'm going to try to do that. It's just interesting stats. All right, I'm going to get out of here. Thanks for stopping in. Yeah, I will see you again in a little less than 23 hours. All right. And hey, there's a moon measuring observation coming up. So if you're interested in doing that, get a hold of me. Send me an email, cosmiclattice@gmail.com, and I will put you on the list. It's super, super easy. It's all you need is a digital camera, and you have to be able to uh, make sure that you have the moon and uh, a bright star next to the moon, and I will tell you when that's going to happen, a date and a time. And you just need to make a photograph of that, make sure the moon and the star or planet is visible. The moon will probably be overexposed. Who cares? Um, but we definitely need both of those things in order to make a measurement. So if you want to get on that list, send me an email. And yeah, that's an interesting project. All right, I'm going to get out. I will see you tomorrow, and peace.